Section 9.4, Arcs and Chords. Look at the circle below. What do you know about angle DOC? Should have said that it should be 56 degrees. What do you know about arc AB and arc CD? Those two arcs are also congruent. Now, if you were to draw a chord between points A and B, and another chord between points C and D, what can you say about the two chords? Well, if I were going to start with this, I would look at those two chords and I think that they're equal, but I've got to be able to prove that. Well, knowing that AO, CO, DO, and BO are radii, we know that they are congruent. I know that angle AOB and angle COD are also congruent because of vertical angles. Therefore, triangle AOB and triangle COD are congruent to each other by side angle side. Therefore, we just proved AB and CD are congruent to each other. Will this work in two circles that are not congruent? Are the chord lengths the same in the two circles? No. So you need to know that the circles need to be congruent or in the same circle or in two congruent circles. This is our first theorem, and I know you can figure out how to prove its converse. In the same circle or in two congruent circles, congruent arcs make congruent chords. Congruent chords have congruent arcs. This next theorem says, if you have a diameter that is perpendicular to a chord, it bisects the chord and its arc. Consider these two radii. If you have these two radii, you know that those are equal. You have an isosceles triangle. If you have an altitude from the center of the circle to the chord, and it creates perpendicular lines, you know that it is a perpendicular bisector. Therefore, you bisected the chord. Not only did you bisect the chord, but you bisected the vertex angle, the central angle, which means that this angle is congruent to this angle, so this arc is congruent to this arc. Another theorem. In the same circle, or in congruent circles, chords that are equidistant from the center are congruent. So consider this chord and this chord. They are both 5 units away from the center. And you know that when we're talking about distance, we always talk about distance being the shortest line, the perpendicular line, from a point to the line. Also, I can again come up with these radii. Those radii will be congruent. Same thing in the bottom triangle. So therefore, this chord and this chord are congruent. Next one. In the same circle or in congruent circles, congruent chords are equidistant from the center of the circle. I'm going to tell you that in this picture, AB and CD, those two chords, are congruent to each other. Your job is to prove that O to chord AB and O to chord CD are congruent. Do a formal 2-column proof. You may add that X is the point of intersection on AB and Y is the point of intersection on CD.